Students, let's look at this question here, which is on lines and planes. Let's see how we can do this proficiently. So determine each of the following pairs of line and plane. Whether L intersects a plane pi at a unique point, lies on the plane or do not intersect the plane. If the line intersects the plane at a unique point, find the point intersection and the acute angle between L and pi. Okay, great. So let's see how I can do this proficiently. I think the first thing is to understand what type of relationship you could have for between the line and the plane. So if you look at our summary notes here, it's either the line is on the line is parallel to the plane or intersecting the plane. Okay, so these are the two main cases here. So the first thing is to evaluate whether d dot n is 0. If d dot n is 0, meaning the direction of the line and the normal, they are perpendicular, it will render the line parallel to the plane. Okay, if d dot n not equals to 0, this is very counterintuitive because in itself the normal is already perpendicular to the plane. So that's why if d dot n is parallel to each other, meaning the line and the plane they are perpendicular to each other. If d dot n they are perpendicular to each other, meaning the line and the plane they are parallel to each other. Okay, so the first thing is I will just evaluate for the part 1 I'll n dot d. So this is 2, 1 minus 3. It's 2, 1 minus 3. Okay. So this case here, very quickly, I can see that this is minus 4 plus 1 plus 9. This is actually not equals to 0. So we will have 6, is it? Yeah. So hence, line is not parallel. If it's not parallel, so this one here is not equal to 0, so n is not perpendicular to d, so I'll just write this down to d. So this line is not parallel to plane. Okay, if they're not parallel, of course they will just they will intersect at a what do you call it, a point, right, a unique point here. So just find it, shouldn't be issue. This is L and this is plane. So if you want to find the intersection point, it's not surprising to know that what we're finding is L equals to P. Just sub the line equation, sub L into the plane equation. That's all. So you take this whole thing here, substitute, because you want to find the intersection point between them. So for example, in secondary school, when you say y1 equals to y2, you want to solve the intersection point. This is y1 equals to y2, right? So similarly, if there's a plane and a line, you just equate them. That's about it. So it's the same concept. You just want to satisfy both equation. That will be, you just sub this whole thing here inside here. So that will be 3 minus 1 plus lambda minus 2 1 minus 3. Then what we're going to do is just dot them. Dot 2 1 minus 3 equals to 5. So that will be I'll just dot them as 6 minus 1 minus 3 plus lambda minus 4 plus 1 plus 9 equals to 5. Okay, so how do I dot them? I'll usually dot them this way. So this will give me this. Then after that, I'll dot this over 2 minus 2 minus this way as well. So this will give me this. So once done, key in calculator, it give me this is 3, then 6 lambda. So lambda is actually equals to half. So once done, the point of intersection, the unique point of intersection will just be this point here. Just substitute into the line equation. 3 minus 1. Okay, great. So be 2 minus half. 1 minus 3 over 2, that will be negative half also. So today on the coordinates, if the line intersects, find the point intersection. Okay, so the point intersection, so this case here, this is actually the plane L, hence L intersects. We try to answer the question, okay, because they ask us the relationship. So point intersection is this over here. Then what we done point of intersection already, we need to find the acute angle. So just remember, this case here, if you're pointing outwards in normal, the normal here is 2, 1, minus 3. The direction vector here is actually minus 2, 1, minus 3. Okay. Very important, the dot product, what you get is essentially, when you dot these two, the angle that you get is over here. Okay. Just remember that. So what we need is this angle here. It's 90 minus theta. So I think it's pretty okay. So what I do is d dot n. Okay, maybe I just put this as alpha instead. This is alpha. Then this angle here that we're going to find is theta, which is 90 minus alpha. Okay. Just know that the angle that we're going to find is, when we dot them, is above. So there you go. We're just going to put these two dot d dot n. Mod d mod n cosine alpha. So I'm just going to dot them. So there will be minus 2, 1, minus 3, dot with 2, 1, minus 3 equals to 2 square plus 1 square plus 3 square, 2 square plus 1 square plus 3 square, cosine alpha. So cosine alpha equals to minus 4 plus 1 plus 9, 14, 14. There will be 6 over 14. Cosine inverse 6 over 14, that will give us 64.623 degrees. Alpha is 64.6. Okay, so the angle between line and plane is what? Angle between line and plane is equals to 90 minus alpha. That will be 25.41 dB. Okay, so that is it. Anything else? I need to find the point of the acute angle. So acute angle between L and pi. Okay, so this is the first part done. So let's look at the second one. For the second one, same thing. You just dot them. So but to dot the normal and the direction, so do minus 3, take the normal. I need to give you 0 here. 2 plus 1 minus 3 equals 0. So hence, since n is perpendicular, this will refer that n is actually perpendicular to d. If n is perpendicular to d, meaning the plane is parallel to the line. Okay, so that's the crux of it. Once you understand that, that's why I always often tell students that the most messed up vectors is about relationship between all these different entities. This part of vectors. So you have the relationship between point and point, point and line, line and line, line and plane, and plane and plane. The most messed up one would be the line and plane as most. So just understand that. So if they are parallel, it's either you could have the line is hovering above the plane. Okay, this case here, or you could have a line which is on the plane. Okay, so this is like D, and this is like the normal here, right? Okay, one way to decide whether which is which is I'm just gonna take this point here and test, because this point here would say that this point is on the line, right? If this point lies on the plane, meaning it will be this case here. If this point doesn't lie on the plane, mean it will be this case here. So I'm going to write now. So sub 210 into L, left hand side of the plane. So there will be 210 dot with 2 1 minus 3 equals to 4 plus 1 plus 0, which is equals to 5, which is equals to right hand side. So hence 210 is on the plane pi. Okay, so this is on the plane pi. So I guess the line L lies, so hence line L lies on plane pi. Okay, that's about it. So it has to be this case because 210 is actually on the plane. So if the 210 is on the plane, then it's parallel, then definitely it's on the plane. The angle between them is it's obviously 0 degrees, right? Because they're parallel. I think that's about it. That's how you do this question here proficiently. If you have any questions at all, please let us know. I'll see you in the next question.